Okay, if you're still with me, we'll finish up with the most complicated situation, which some people might consider the most fun. And that is when you have the full catastrophe. You have level, which might be changing, you have trend, which might be changing, and you have seasonality that might be changing. So you have three separate things to keep track of, and guess what? There'll be three knobs: an alpha, a beta, and a gamma. And each of them would be between 0 and 1, and there's a best combination of the three that would give you the most accurate forecast. Again, the choice of what those values are, how those are computed, is left for another one of these little chats. But this method, because it deals with seasonal data, requires a third equation, one for level, one for trend, one for seasonality. And this particular manifestation of the algorithm was invented by a professor happily named Winters. So if you hear Winters method, you could think of, accidentally, winter is a season. At least it is up here in Boston. And so Winters method is for seasonal data. And we have an equation for level, an equation for trend, and an equation for seasonality. And these there's some subtle adjustments where these feed into each other, just the way with Holt's method. The equation for estimating the trend term was using the results for estimating the level. So again, we're going to have alpha times something plus 1 minus alpha times something else. We're going to have beta times something plus 1 minus beta times something else. And now we're going to have gamma times something plus 1 minus gamma times something else. So details aside, you can see that what we're doing is we're just using the same simple exponential smoothing 3 times. We're doing it separately for each of the 3 constituent parts of the underlying data: its level component, its trend component, and its seasonality terms. And we should mention that there are really 2 flavors of seasonality, both of which have their own version of Winters' method. There's so-called additive seasonality and there's so-called multiplicative seasonality. And we can talk, I hope I'll remember to tell you about how you can spot the difference. But basically, the simple explanation is, if the size of the seasonal swings is basically constant over time, you're just adding something in the seasonality, it's additive. But if the size of the seasonal swings is getting bigger and bigger as the data values trend up, then on a percentage basis they're constant, but on an absolute basis they're not. And that's the tip-off that you've got multiplicative seasonality. So there'd be a different equation down here depending on whether you, and actually the details are a little different whether you've got additive or multiplicative. But to make that point a little bit visually, if you have additive seasonality, you've got a picture like that. That's additive. And multiplicative, let me give myself a little more space. Multiplicative goes something like this. You see the size of the swings isn't constant. It's getting bigger as the data goes up or smaller as the data goes down. So multiplicative is like that, additive is like that. Okay, so what are these 3 equations? Now the computer would again be doing the heavy lifting, and with a little extra calculation it will suggest values of alpha, beta, and gamma. But in most software you have the option to just grab the controls, turn off the autopilot and say, I'm going to tell you what alpha, beta, and gamma should be. Now we're going to be looking here at multiplicative as the case we look at, multiplicative. So we know that the level says, tell me where I am now, and then here is where we thought the level was last time. And remember, we think there's a trend, So where the level was last time plus the amount we've trended up, that's the current idea where the middle of the data is. This would normally be the current data value, but if there's seasonality that's multiplicative, we need to put in a deseasonalized value there. We've got to take the seasonal factor out of it. So if the seasonality is a multiplier, like every January we go up by 10%, then we want to divide this by 1.1 to get the seasonality out. So we're going to call this, this will be S of t, this is B of t, of course, and we'll call this C of t, the seasonal factor. So we're going to take, deseasonalize this. We're going to take the seasonal multiplier that happened one season ago. So if this is the January number, we look at what we thought the January multiplier is and we divide by it to take it out of the picture. So this is a deseasonalized observation. And by the way, one of the things you do with Winters exponential smoothing is you get these seasonal multipliers, and if you want to do your own seasonal adjustment to your data, that's a byproduct you can get out of Winters' method. But here we're doing a seasonal adjustment of the level. And this is how we say the basic underlying deseasonalized level of the data is. If you were reporting, say for financial reports, what's our current level of sales on a deseasonalized basis, you could stop right here. Of course, you have to know this and you have to know that, so you have to still do these calculations. But this is the one you'd be aiming at as your output. Now, with the trend, we need to know what our current level of trend is. And that's basically what we saw before. We have the same as in Winters' method. We have the previous estimate of trend. And here we have the change in the deseasonalized smooth. So that equation hasn't changed. This one did to deseasonalize. This is the same as Holt's method. And now we have to think about what are we doing here. Well, we have the seasonal multiplier for a given month 12 months ago. S is the seasonal length, like 12 months. If you're using accounting months, S would be 13. If you have quarterly data, then S would be 4. If you have monthly data, then calendar months, then S is 12. So you say the current idea of what the January seasonal factor is what we thought it was last year, plus an adjustment about what's happening now. And that adjustment is just the opposite of this. We can take our current data and divide by the value that we think the level is, and this becomes the equivalent of a seasonal multiplier for this year. So last year the January effect might have been add 10%. This may tell you that this year the January effect is add 6%, because that seasonality might be petering out. Or it might say instead of 10%, it should be 13%. But these calculations, where this one has been fed by this, and this one has been fed by that, they connect to each other. And you step through for each time period, and you get these 3 estimates, and you combine them all when you finally make your forecast. So if you're making your forecast, say x hat at the current time plus some horizon, like maybe 1 month ahead or 3 months ahead, 24 months ahead, we would say, just as we did with Holt's method, our current idea of the middle of the data, S at capital T, plus the slope, the trend estimate we think, times H periods ahead. So if we're going up by, say, 10,000 units a month and we're going 3 months ahead, we'd add 10,000 times 3, 30,000 to wherever we think we are now. But then we have to multiply it by the appropriate C. And that C would be the C for T plus H. And T plus H will end up in a certain month. So we're going to need to know what the C is for that month. So this is basically Holt's method adjusted for the fact that there's a multiplicative factor for what month you're in. This is deseasonalized data. This is an estimate of the seasonal multiplier. It all hooks together in a pretty complicated set of 3 equations. So you wouldn't want to do this by hand on a calculator. You'd want software to do it. But this turns out to work pretty well for data that looks like this, and allows you to make forecasts that account for not only the trend and the seasonality, but the fact that the trend may be changing, maybe it's moderating. The seasonality may be shifting as climate changes. Maybe your Novembers aren't quite so cold anymore and you can sell more of your lawn products. And it takes account of drifts in the overall market. Maybe the economy is going up and so you can sell more stuff